Good morning, everyone. Good morning. Be out there? Good. How's everyone today? Welcome to our third More Than the Score for the season. And we've got 3 more after this, so hopefully you'll come back again and again. It's our 11th year of producing More Than the Score, and we're really excited to give you another great year of wonderful faculty speakers from UVA. So we have a great lineup today. Michael Stratoff, who is the Executive Director for the UVA Licensing and Ventures Group, he's assembled a brilliant team to kind of share with you today some of the wonderful inventions happening right here at UVA. So he'll be introduced in just a few minutes, and then he'll introduce his great assembly. Before we begin, if you'll go ahead and just silence the ringer on your phone. We are recording today's lecture, so we ask that you wait for the microphone to reach you to ask your questions at the end. We've also passed out those great orange feedback cards. We do use those to plan future More Than the Score programs, so please give us your comments, your feedback. Like I said, Michael will be introduced by Tom Falders, who is President and CEO here at the Alumni Association. He'll be introducing Michael in just a few moments. But just for fun, how many are going to the game today? Great, wonderful showing. How many came just for the talk, just to hear the talk? You guys are my new best friends. Thank you. Thanks for making my job fun. Thank you for being here, and welcome. Tom, all yours.
Thank you, Althea. Althea and her team do a wonderful job, and I reflect back, we started this about 10 years ago. With an idea that Ed Ayers kind of said, you know, I have all these alumni coming back for a football game, but you get tired of walking up and down the lawn every once in a while. Is there something we can create where we can showcase some of our great faculty? And so we played with it, and we tried, a year earlier we had one that we tried over in the chemistry auditorium, and we said, yeah, we ought to probably do that. What I hadn't figured out was this ballroom was under construction, and so we had a big tent out front. For the first year of the More Than the Score, and we started with, I think, 25 people showed up at the first one, and then 35, and then 70, and now we have the attendance we have today, and it's turned out to be one of these really great events. And I was telling Michael, I go to these meetings annually with my counterparts, and my counterpart from the University of Alabama came up to me at one of these meetings and said, I heard a rumor that you all have an academic seminar on the morning of game day. And I said, yeah, we do. And he looked at me with this really quizzical face and said, does anybody come? And I allotted as, yes, quite a few people came. And he said, that would never work at the University of Alabama. So anyway, good morning. We have a beautiful day for a truly inspiring More Than the Score. You may or may not know it, but there's a lot going on here at the university when it comes to innovation, interesting ideas, entrepreneurship. There's an emergence over the last few years of a truly vibrant community within the university community. And it covers all the schools. It's not just one school. Every school, all the 11 schools have some sort of entrepreneurial activity. And it's truly heartening to see the emergence of this. And you'd think in entrepreneurship, a kind of a centralized approach to things would be anathema. Well, there's actually something called a entrepreneurial advisory committee that's trying to coordinate activities and make a community self-sustaining and being able to share good ideas as well as share resources. And that's starting to take hold too. Among the leaders in the enabling of all of this is the university's licensing and venture group. What used to be known as the UVA Patent Office has morphed into an innovation engine for the university, and is due in no small part to its executive director, Michael Stratoff. Michael joined the University of Virginia Licensing and Venture Group as a director in September 2014 and became the executive director in 2014. He was previously a director of biomedical engineering commercialization at Case Western University in their technology transfer office. He managed a high-profile research, development, and commercialization partnerships with several large biomedical technology companies. And he was also involved in the formation of companies spun out of CASE in coordination with CASE Technology Ventures and the local community. He was formerly a senior licensing associate consultant for a small engineering school down in Southwest Virginia, where he managed a diverse portfolio of technologies in engineering, physical sciences, and life sciences. He's also worked as a patent examiner at the U.S. Patent and Trademark Office after serving as a research assistant at the Cleveland Functional Electrical Simulation Center. So Michael comes with a great degree of experience, and he's brought a great panel, and he'll introduce those. So Michael, thank you.
Great. Thank you so much. Thank you, Tom, and thank you all very much for being here. Welcome home. I'm really honored to be with you this morning and talk to you about something about which I'm very passionate, and also my fellow panelists are very passionate, and that's innovation at UVA. So there have been 2 home football games now, and accordingly 2 more than the score addresses. And as far as I can tell, it seems that there's a pretty apparent theme of talking about the future. Professor Sabato has been predicting the future in American politics now for years and years and years. And Alice Raucher, the university architect, is now designing the future of Jefferson's grounds. And so you might think, after prominent Larry Sabato and then the university's architect are presenting, what are you going to talk about, Michael Stratiff? And my argument is that the University of Virginia Licensing and Ventures Group is too working to show you the future and to deliver the future. We're working today on what drugs you will take when you get an infection tomorrow. We're working today on how we'll diagnose your disease in the future. And we're working today to solve the energy demands of the future economy. And our job at the UVA Licensing and Ventures Group is to support the university's efforts to transform research, discoveries, inventions, and works into future innovations. But before we talk about the future, we're going to do a little bit of a history lesson. Okay? So let's talk a bit about the past and how we arrived at where we are today. Our founders recognized the importance of invention and innovation at the founding of our new nation and established the foundation for intellectual property rights in the Constitution of the United States in Article 1, Section 8. This is really, really foundational for our work in that the establishment of intellectual property rights in the United States are built upon the objective of promoting the progress of science and the useful arts. Now, we may all read about patents and anti-commercialization efforts, but we at the University of Virginia really try to use the patent system to promote that progress of science and the useful arts, and we'll talk more about that in a few moments. But for us, it's a little more personal. It's a little more part of our culture at the University of Virginia. And as many of you know, Thomas Jefferson was a prolific innovator and also the first patent examiner of the United States. And he believed where a new invention is supported by well-known principles and promises to be useful, it ought to be tried. And the key in this is that it ought to be tried. It ought to be implemented. It ought to be disseminated for the benefit of society, to promote the progress of science and the useful arts. So first fun trivia of the day, and I'm going to ask more difficult questions. I've seen some of these questions like, who is that? We're not going to do that. To what prominent American innovator was Thomas Jefferson writing when he said this? Does anyone know? Not Franklin. Robert Fulton. About what innovation was he talking? Not the steam engine. It wasn't for a boat. Well, it's maritime. It was the torpedo. He was trying to sell the torpedo to the United States government and was ultimately implemented by the British Navy. So there was our first fun trivia of the day. Okay, so Thomas Jefferson said this in 1810, which brings us very logically to 1980. Okay? I'm certain that there was some level of innovation taking place in the United States between 1810 and 1980, but it was inconvenient for a 45-minute talk, so we're just going to skip ahead to 1980. Does anyone know who these two gentlemen are? I'm hearing Bob Dole pretty resoundingly. Who's the other person? Birch Bayh. Who got Birch Bayh? Good for you. Are you from Indiana? No? All right, great. Well, so in 1980, the United States federal government, which funds the vast majority of research in the United States, commissioned the Congressional Budget Office to do a study and to look at the fruits of that research and the results of that research to benefit the taxpayers that funded the research. And they found that at that time, the federal government owned 28,000 patents, of which 5% had been commercialized and disseminated to benefit the taxpayers that funded the research. And they said, this is a broken system. The federal government owning the fruits of university research is not productive. We need to change this paradigm. And in 1980, they enabled the universities that create the research to elect title to those inventions and to manage its dissemination throughout the world. So in 1980, technology transfer offices like the Licensing and Ventures Group start popping up all over the United States. UVA was ahead of the game, and in 1977 founded the UVA Patent Foundation. At that time, it was the UVA Alumni Patents Foundation. And in 2014, UVA reaffirmed its commitment to innovation and commercialization in its cornerstone plan, Pillar 2 of which reads, our goal is to strengthen the university's capacity to advance knowledge and serve the Commonwealth of Virginia, the nation, and the world through research, scholarship, creative arts, and importantly, innovation. Okay? And again, look to the beginning of this sentence, to advance knowledge. The university advances knowledge in many ways, educating students and disseminating them throughout the world, performing research and publishing papers, and in many cases, patenting inventions and commercializing those inventions for the betterment of society. And we're going to spend the rest of the talk emphasizing that last part. I'll also add that innovation is no longer an extracurricular activity for universities. It's becoming core institutional value and core institutional responsibility. The federal funding agencies now expect that the results of that research be commercialized. The Commonwealth of Virginia increasingly expects the University of Virginia to engage in economic development activity. And most importantly, I think, increasingly potential faculty, staff, and students of the university want to be in an environment where they can see the fruits of their research benefit mankind. So it is a really critical institutional value that we engage in this innovation activity. So how do we do this? The UVA Licensing and Ventures Group, the organization that I'm a part of, its goal is to maximize the impact of innovation assets via commercialization, while providing high levels of customer service to our faculty, value-added business development, driving these innovation assets to market, launching new ventures, and driving quality business transactions with our partners. And we're going to talk about now how we do all of those things. So what is our process? Hypothesis-driven research at the University of Virginia drives a large volume of creativity and invention. It is the job of the Licensing and Ventures Group to interface with the faculty, staff, and students of UVA to solicit those disclosures of invention and to work with those faculty members to seek their downstream commercialization. The first thing we do upon receipt of those invention disclosures is evaluate those disclosures on the basis of advancing this knowledge. So what is the best mechanism to advance the knowledge? Is it just to publish the paper? Or is it to file for patent protection and seek commercialization? And we evaluate these technologies through three lenses. We look at the technical merit and the technical readiness of that technology. We look at the intellectual property protectability of those assets. And most importantly, we try to determine whether or not a commercial market exists for those disclosed innovations. If that technology and that disclosure passes all three of those tests, then we'll seek patent protection or other copyright protection to protect those inventions and to entice an ultimate transaction with a commercial entity who will take the technology all the way to the marketplace. In many cases, however, the research that comes from the university is not quite ready for commercial adoption. So you end up with what's very well known as the valley of death. and we seek to try to traverse the valley of death. And we use many, many different mechanisms, one of which is our translational research programs that we'll talk about a little bit further. We have a team of 6 licensing professionals that are engaged in business development in high volumes all day, every day. We ultimately execute commercial license transactions with our partners to drive those assets to the marketplace. We launch new ventures, and ultimately, hopefully, we generate revenues that we distribute and reinvest back in the infrastructure to support innovation and scholarly activities. But it takes a huge volume of people, programs, places, and resources to support this long, long continuum from ideation to ultimate innovation. The UVA, the Licensing and Ventures Group, the team at the UVA Licensing and Ventures Group includes 4 PhDs, 2 patent attorneys, 1 patent agent, and 4 people with MBAs. We have a team of 15 people that all work in this process to drive these assets toward commercialization. But I would assert that the most important asset of the University of Virginia in seeking commercialization of technology that originates at UVA is you, the Alumni, Friends, and Family Network of UVA. As you can imagine, diverse interests, diverse research endeavors at UVA drive innovation in domain spaces as broad as the university's research interests. As a result, as a questionable biomedical engineer myself, I need a lot of help to evaluate these technologies, and I reach out to UVA's Alumni, Friends, and Family Network almost every day. It is an extraordinarily powerful network. Within about 2 phone calls, I can get to almost anyone and find domain expertise and best-in-class commercialization advice from the UVA Alumni, Friends, and Family Network. We also hire entrepreneurs in residence. These are entrepreneurs that come into our portfolio to evaluate our technologies, to try to evaluate launching new businesses around them. We have a Virginia Center for Translational and Regulatory Science, where we have top-quality medicinal chemistry and regulatory advice to support our drug development efforts. And students, students, students. There are students associated with a high majority of all of our invention disclosures. Graduate students and professional students are driving a huge volume of innovative activity, and we leverage their expertise, as you'll hear about a little later, to help us drive these assets to market. Programs. I'm going to speak very specifically, really quickly, about our translational research programs. Our translational research programs are the dollars and programs we deploy to traverse that translational valley of death. Okay? We are blessed at UVA to have 3 philanthropically financed translational research programs. These programs are staffed by interdisciplinary committees of internal and external advisors who help us pick technologies to invest our precious dollars to advance those technologies to the marketplace. The catalytic program at UVA is the Wallace H. Coulter Foundation. Wallace H. Coulter was the founder of the company that ultimately became Beckman Coulter. And in 2010, the Coulter Foundation endowed the University of Virginia with a $20 million translational research program. And so we deploy these dollars, about $1 million a year, to advance these innovation assets ultimately through commercialization. There are many places around UVA, and I hope you've had a chance during your visits to Charlottesville to see these places. The UVA Licensing and Ventures Group, our office, is located at 722 Preston Avenue in the old Coca-Cola building on Preston Avenue. We have 10,000 square feet of innovation and entrepreneurship space. The University of Virginia also has a magnificent iLab facility on North Grounds, and I encourage you to go and visit that space. At any given point, there are probably 25 new ventures being launched out of that physical facility, and Eric Brewhouse will talk to you a little bit more about that. Open Grounds. Open Grounds at the Corner is an interdisciplinary ideation space where we try to cultivate innovation across multiple domain spaces where people aren't. We're bringing people together from the disparate corners of the university. And resources. This is one of my favorite new programs at the University of Virginia. In 2015, UVA launched the UVA Seed Fund. This is a $10 million investment fund where we are investing in companies established by UVA-affiliated people to commercialize UVA-affiliated ideas. So we invest dollars to drive these companies to the marketplace. So by the numbers, we've talked about what our process is, what our people, programs, and resources are. What are the numbers? So UVA performs about $350 million worth of research each year. As a result of that research, we receive at UVA LVG approximately 200 reports of invention each year. Our 6 licensing professionals manage the due diligence process associated with those technologies and ultimately drive approximately 80 commercial transactions every year. We have 2 patent attorneys that file over 100 patent applications a year, and we have 1 new ventures specialist that launches between 5 and 7 new companies each year. So stated another way, graphs trust me on this one. Data going up is really good in the cases where the data is going up. Data going down is really good in the cases where the data is supposed to be going down. This is really good data. Just trust me on that. But now we're going to talk about probably what's going to resonate most with you. Innovations at UVA are very, very diverse. They're big and they're small. The smiling gentleman there on the left is the Rolls-Royce Commonwealth Professor and Chair of Mechanical and Aerospace Engineering, Eric Loth. And he has designed wind turbine blades that are 656 feet long to mimic palm trees, because palm trees are remarkably resilient in storms. And so that's Eric standing next to some palm trees. But they're also very, very small. I'm holding in my hand a blood glucose meter developed by Sanofi that includes technologies developed at the University of Virginia to monitor patients' blood glucose and better control that blood glucose. UVA innovations are complex and brilliantly simple. And I have to read the complex one because it is a chiral spectrometer developed by Brooks Pate in chemistry based on principles of Fourier transform molecular rotational resonance spectroscopy for differentiation of diastereomers without chromatography. So that's you all got that. But they're also brilliantly simple. This gentleman over on the right is Lou Bloomfield. Lou Bloomfield developed a totally novel class of polymers because he got irritated that tables were wobbly. And he wanted to come up with a material to make tables less wobbly. Interestingly, though, this novel class of viscoelastic polymers now is finding applications throughout the world in many domain spaces, from helmet linings to golf grips to hearing protection. And we also have UVA innovations, lucrative and more designed for public benefit. The top machine is a mass spectrometer marketed and manufactured by Thermo Scientific that includes UVA technology originating from Don Hunt in the chemistry department. But we also have companies that have elected to cap their profits, to reinvest in the dissemination of their technology, which in this case is a ceramic drop to make drinking water safer. Okay? And now I have the pleasure of introducing the folks that are going to really tell the exciting part of the story. First and foremost, I'm going to introduce you to Eric Brewhouse. Eric is currently responsible for business development and operations at Psychic, which is one of UVA's most exciting portfolio companies. Eric's a former Division I soccer player that worked for Johnson & Johnson for a while, and then came to UVA to study at Darden. And during his time at Darden, went through our iLab translation program and entrepreneurship program, and is going to talk to you about his experience as a student, commercializing university research, and then also about his role at Psychic. Mm-hmm.
Well, good morning. I think it was maybe 10 minutes ago that I just realized what that experience in the iLab was, and it was Michael pushing me headfirst into his valley of death. And that's not the way it was sold to me at the time, but upon getting to Darden in 2012, I just fell in love with startups, and every single day working and just feeling the impact of the actions that you're doing on a day-to-day basis, and got connected with a UVA technology that had developed a novel MRI protocol that could get really granular muscle data about your individual muscle structure. And then the idea at the time was to give surgeons a better roadmap before going into surgery about how to complete the procedure that they were going to be doing on their patients. And at the time, I think the economic value of that kind of fell apart as soon as you started to look how expensive MRIs were. But where I came into the picture was, as Michael mentioned, as a former college athlete, they had this idea, what if we could use this technology to help high-performance athletes be trained better, be at less risk for injury, and rehab more efficiently from severe injuries. So where I came in was these professors had developed this novel technology but had absolutely no idea where is the pointiest end of the stick, and if this does have value to the commercial markets, how do we actually get there? So my journey of the Valley of Death went through the iLab, as he was mentioning. It's a fantastic institution that had been developed right when I became a student, and they foster 20 to 25 ventures at any given time, half of that being student-led ventures as well as ventures from the community, ranging all sorts of different directions, from consumer products, medical devices, financial technologies, you name it, they run the whole gambit. And that infrastructure was fantastic for me as a student, because it's my first time running with a technology and learning how to implement that into the marketplace. You need a lot of help. I think Darden is famous, and if you meet any newly minted Darden grads, they are going to be all hopped up in coffee that's been infused with a double shot of confidence, and everyone coming out of that institution is incredibly smart, and they all believe they can take over the world. Walking through Michael's Valley of Death was a very different experience for me, and I think after those 2 years of constantly hitting failure after failure after failure with a small success thrown in, you realize very quickly I was not ready to run a company coming out of there. But my experience in assisting the faculty members take this technology, identify exactly how it can get to the market, prepared me very, very well for the next venture. And as Michael mentioned, I'm currently have been with Psychic, a local semiconductor company that was spun out of UVA for the last 2.5 years. And the value from my experience running through the iLab was that I learned all the different ways that you can fail and how difficult it is to take a new technology that is ultimately unproven and explain the value to the marketplace and figure out how you're actually going to get there and convey that value to ultimately customers and raise money from investors. So with Psychic, that has been a phenomenal opportunity, because contrary to all of my other classmates, I knew I couldn't run a company yet, and I got the opportunity to join a company and sit next to a very highly talented CEO, Brendan Richardson, for the better part of the last 2 years, and every single day learn how you can successfully navigate those waters of bringing a technology to market. Psychic is a truly groundbreaking technology that came out of our founding CTO's work, both here at UVA and the University of Michigan. What we do at Psychic is design the world's lowest power semiconductors. Where that is applicable is if anyone has heard of the Internet of Things, that is the next big buzzword that's going on in tech circles. People are comparing that to be having the economic impact of the next industrial revolution. If anyone thinks about the way that these computers have evolved, they used to be the size of that back room and cost hundreds of thousands of dollars. As we've evolved over the last 50 years, these cell phones that we have in our pockets are modern-day miracles. They are absolutely miracles. If you applied the same rate of performance and cost reduction that we have in the semiconductor world over the last 50 years to cars, you could drive, everybody in this room could drive a McLaren on a single gallon of gas for the rest of their life, and it would probably cost you about $50, and you could circumnavigate the globe at the speed of light around 500,000 times. So those cell phones that you have in your pocket are absolutely modern-day miracles. Where Psychic is different, the entire industry has been focused on bigger, better, faster, stronger. Every single year, every 2 years, your computer doubles in the speed and the processing power that it has capable. What we're focusing on at Psychic is completely different. When going back to the Internet of Things, if you think about these new evolutions of computing devices that are going out in the world, they don't have to be incredibly complex. Many, many big companies are calling for trillions of sensors to be out in the world by 2025. And a lot of these sensors are going to just be built in the ambient world around us. It's not meant to be creepy. You're not going to know they're there, but they're going to be making intelligent decisions about what's going on. If you pull up to a stoplight in the middle of the night and it's red, it's probably going to know that you're there and turn green immediately. We're going to have smart city infrastructure. We're going to have smart buildings. We're going to have temperature sensors lining every room in big skyscrapers, and the heating and air system is now going to be more efficient. We're going to have these types of sensors built into the entire world around us, but where it breaks down is if you try to power 1 trillion sensors on batteries, it will never work. I mean, I'm a millennial. I can barely charge my cell phone. My laptop, when I show up to the office, is usually dead. If we try to tell the rest of the world to go around changing batteries, it will never, ever happen. And that's where Psychic comes in, and I think that's where our groundbreaking technology is going to be unique, is that the work done by the founding faculty members and CTOs and their academic groups was done over the period of almost a decade of research, doing continuous design works with the idea of building fully integrated chips, full systems that were capable of operating on a power budget that was so low that you could harvest the amount of energy required from the world around you. So indoor light from this room, or body heat, or vibration, motion of your arm would be enough to power the entire system. Run data on the chip, send the data off somewhere wirelessly, get it up into the cloud, and now we have a smart world. It has been a wild ride for me as a student contributing to university research. I think Psychic is one of 3 semiconductor startups across the entire world. Venture capitalists and investors have stopped investing in semiconductor designs because it's an incredibly capital-intensive industry, and it takes way too long to get to market. The reason that we've been successful, and one of the other startups that's alive and in the U.S. also spun out of university technology. The reason it's possible is because our founding professors and their academic groups were able to spend 10 years thinking about what the future is going to look like and designing chips for that without having the pressure of delivering near-term results that big companies like Qualcomm or Texas Instruments have to do. Those companies, when they talk about innovation, are innovating for a year from now or 3 years from now. The technology that we're working on and developing and commercialize is innovating for the Internet of Things that's going to be around 10 years from now and beyond. So my experience as a student has been fantastic. I think it's been a win-win for everyone involved because I've been able to really put in the time and hours to help think through the commercializations in your valley of death. And for me as a student has been a wonderful experience to learn all the difficult ways you can screw up. So down the road you can make more intelligent decisions.
Great, thank you. I now have the pleasure of introducing the brains of our panel today. No offense to the others here, but listen to this. James Landers is the Commonwealth Professor of Chemistry, Mechanical Engineering, and Pathology, is one of UVA's most prolific innovators, and is a serial entrepreneur. So, without further ado, James.
Thank you, Michael. Michael mentioned hypothesis-driven science. This morning, Michael texted me and said, I'm wearing a sports jacket. You'd better wear a sports jacket. So my hypothesis was Michael was going to wear a sports jacket, and he wears a sweater. Now, on the topic of Michael, I've been here for almost 2 decades. And in fact, I was on the search committee that actually hired Michael. And it's interesting because on that search committee of 8 individuals, there was a substantial amount of pushback because Michael was young. He was very, very young to come in a relatively high position. And I opposed that notion on the committee, and we finally drove it through. And I can tell you that Michael has revolutionized with LVG the way research is done here and how that research can be translated into products. So a lot of what you hear from Michael and what you sense now about the translation of science and technology into actual usable products comes from an ecosystem that Michael Stratoff has actually created here. So I think he deserves fair credit for that because I remember the days that were not so good. So the gizmo on the screen is a gizmo that goes to the heart of all the information's in your DNA. And what does that mean? Well, we know that your DNA holds some answers in terms of longevity, possible familial, family-related things that will ultimately lead to disease at some particular time. That instrument is a very simple instrument that extracts DNA out of samples, blood, cheek swabs, tissue. And it's not really all that exciting. What's more exciting is that that technology has now been wrapped into an instrument that I think we can all relate to a little more. And that instrument is something that's about the size of a Blu-ray player. And that instrument is now going to be deployed by the DoD. And in fact, the Special Forces, come January, for testing in Iraq and Afghanistan, where they will take cheek swabs, cells from the inside of cheek of some particular individual, put that swab into a system that incorporates that and other technologies that we've all filed patents on through Michael, and that will pop up the image of an individual based on their DNA. In other words, it becomes the DNA equivalent of fingerprints. Difference is you can't fool it. DNA is DNA. And so the idea here is that the Special Forces want to obviously keep America safe, and this is a way to essentially hunt down people that they are suspected of anticipating doing not so good things, and essentially use that instrument to compare with a watch list and define whether or not they've got somebody that is a person of interest. Now, what does that have to do with all of this other than it's technology that, at least in a global sense, we can all appreciate? That technology, including this technology, was built in my lab by graduate students, PhD students, who probably spend 4 years of hell in my lab getting their PhD, but when they get out, they do really great things. And the team that currently exists with this DoD-funded research, which, by the way, has brought $5 million to UVA in the last 2 years, is a team of 20 PhD and senior scientist level researchers, incredibly creative people. In that 20 people, there are 14 graduate students, so people out of University of Richmond and University of Cincinnati who come here to get a PhD because they're interested in this kind of research. And what drives them is the fact that that instrument that we talk about is actually going to do all of the chemistry on this. So this is a CD-sized chemistry lab, essentially. And what's interesting, and when I talk about this technology and talk about the fact that this will do everything that an entire laboratory bench of instruments will do, and talk about the fact that we make it out of overhead transparencies and that we drive it, use as a reader, a Sony Discman, most of the people that I talk to tend to go, "What's a Sony Discman?" Or "What's an overhead transparency?" We can relate to that. But 14 of those are graduate students. And the really awesome thing about doing research at UVA, not only having a conduit to take your research to market, is that we've got 21 undergraduates in my lab. 21 undergraduates who, as you know, UVA students, including my daughter, who's a third year, commit to way too much extracurricular activity, and yet they manage to find 10 to 15 hours a week to come and work in the lab with PhD students and postdoctoral fellows and senior research scientists and learn how to do science. And I think this is an important part of President Sullivan's mission in terms of education shouldn't simply be about sitting in a classroom. We've got to plug these students in. So with that, I think I'm going to close off by saying that Michael's group, Michael's team, has been critical in helping us sell this, because this is now on the market for sale and we've sold some. But it's important in a way that people don't realize that what Michael does at LVG, which may seem removed from UVA, is actually really well integrated into what we do with graduate students and undergrads, and I think that's really important. So thank you. Pass some of these around in case you're interested.
Thank you so much. I now have the pleasure of introducing Chad Rogers. Chad is a UVA grad, also, interestingly, a Division I college soccer player. But Chad, when Chad left UVA, he's been an investor, he's been a C-level executive at several startup companies, and ultimately moved back to Charlottesville and launched a new business around a university technology that has potential to really transform the way patients manage their diabetes. So Chad.
Well, first of all, thank you all for being here, and we really appreciate you taking the time to hear what we're doing. As Michael said, I came back to Charlottesville about 4 years ago after being in Boston and San Francisco, and I happen to enjoy living in the Valley of Death. That's what I've been doing for about 15 years now, with small companies, trying to help them evolve and develop from ideation, and oftentimes they get very stuck because ideas are easy. Translating them to something that works is very hard, and either because I'm not very smart or because I like to run into these things, I spend a lot of time helping companies understand what to do and how to get there from this point. So about 4 years ago, I started playing around here in the university and asking people what was going on as my wife and I looked to maybe move back to Charlottesville, like a lot of people say. Wouldn't it be nice to come back here if I could find something to do? Arrogantly, I said, I can do what I do from anywhere. Which is never as easy as you make it sound. So I showed up, and Michael gave me the opportunity to sort of walk around inside of the university and said, go, find anything you're looking for, dig around, look at our patents, look at new technologies, and just and play around and see what's there. And if you find something you like, come talk to me and see if you want to take something out. Well, lo and behold, I worked on a number of different projects, some that didn't work that well. I ended up getting involved with a company called Hemosonics, which was doing coagulation, point-of-care diagnostics, and helped them for about a year, kind of getting turned around and get moving. But along came an asset that Michael had brought to me and said, look, there's a series of technologies in the Center for Diabetes Technology at UVA, which strangely lives in neurobehavioral sciences and psychiatry. And they had invented some very interesting components sort of in the mobile space as well as the diabetes space. And I got together with the founders, and we started the company called Type Zero Technologies. So what are we? Type Zero Technologies is a company that is working on diabetes management. And that's very generic, and it can mean a lot of different things. But not to be too much of a downer, unfortunately, diabetes is just an incredible pandemic that's coming down the path. More than most people understand. And we hear it all the time in 2020, 60 Minutes, news story of the day. There's about 30 million people in the United States who have type 2 diabetes. It's about $245 billion. The CDC just came out and said by 2050, about 1/3 of Americans will have type 2 diabetes. So that's about 100 to 150 million people. If that happens, we're all in a lot of trouble here. Our healthcare system and everything else is going to go in a very, very bad way. So what are we doing? We're trying to build tools and analytics that can truly change this whole paradigm and make this a lot better. And how do we do it? So we do it through 3 ways. We basically use algorithmic technologies and advanced metabolic models. These are things that were invented over 10 years, $50 million worth of research from NIH, JDRF, private funds here at the university, in a large lab, probably maybe the most prolific invention center here at UVA. We take those technologies and we combine them with human-centered design and applications, and I'll explain that in a second. And lastly, we wrap that around with artificial intelligence and machine learning. And what that produces is these solutions that truly take the burden of diabetes away from the patient in sort of an autonomous way. All right, so that all sounds really great. What does it mean? Well, you may have heard, and it's starting to become a little bit popular, something called the artificial pancreas. Well, the artificial pancreas is one of our instantiations. And really what it is a set of algorithmic and computational technologies that we've translated into a mobile environment. So it's listening to a continuous blood glucose monitor, which is a small device that you stick into your body. For a lot of people with type 1, they wear them. Not so much in type 2, but it's coming because they're relatively expensive. So this reads my blood glucose every 5 minutes in your interstitial blood. Takes that information and, excuse me, I'll turn this on. So we have a mobile application that can listen and take this information. So every 5 minutes, we're basically reading your blood glucose and trying to understand where you are, where you're going, what things you may be at risk for, and then ultimately we control an insulin pump. And so it basically acts as your pancreas. When things are changing, we dose more insulin to bring you back into range. When you're starting to go low because you're over insulinized, we'll cut back on the insulin to make sure nothing happens. And it sounds very simple, and most people ask, well, how is this not possible? How did these two devices not talk to each other before? Well, it turns out it's just more than a thermostat. It's a little bit hard to do because humans are a little bit complicated and don't do what we all think they should do. But that's what we've built, and this technology has gone for about 10 years. About 7 years of it were done inside of UVA, and we've been working on it for the past 3. We're entering a clinical study here at, let's see, it'll be 240 patients in 11 centers around the world, 3 in Europe, 7 in the United States, UVA being one of them. And this will be the pivotal study for this technology. We've licensed it to this company, or one of the companies we've licensed to, which is Tandem, a public company out of San Diego. They're embedding this technology inside of them, as well as some other big companies, which will be coming soon. So what we're doing is taking technology that was invented at UVA, and we've really pushed it out in the world for something that will dramatically change patients' lives, and definitely in the type 1 space, and ultimately we're translating into the type 2 space to do the exact same thing. And these are the types of things that exist inside of the University of Virginia that sometimes people don't realize how powerful these technologies can be. And for people like myself, bringing them forward both for our company, but also for UVA to really show what is showcased here and what can happen is really why this is so much fun for me. So yeah, it's been a good couple of years, but we have a long ways to go. So hopefully you will hear more about us in the coming years. So.
Thank you, sir. Yeah, you're fine. You're fine. Great, so I hope we've convinced you that there are amazing things taking place at UVA on the innovation and commercialization side of things. But one of the things, other than obviously these highly impactful stories that you've heard, is how do we measure the impact we're having? I think most importantly, we're looking to improve human health and the human condition. And I've highlighted here a handful of things that I think are extraordinarily impactful activities taking place at UVA. A faculty member named Randall Moorman conducted a big clinical study and realized that he can take discarded data from the neonatal intensive care unit and use that data to predict the onset of sepsis, that if the physicians in the neonatal intensive care unit knew about earlier, they could intervene and reduce infant mortality in the neonatal intensive care unit. Originated at UVA, now in a company commercializing this technology. A faculty member named Paul Hoffman in our infectious disease division is working to develop new antibacterial drugs for a new century. As we hear about antibiotic-resistant bugs and pathogens, we have UVA efforts to eradicate those illnesses. If anyone has students that grew or children that grew up in the Commonwealth of Virginia and studied in Virginia public schools, they likely learned to read, at least partially, through technology developed at UVA's Curry School of Education, through the PALS program. And finally, we've also talked about Modi Drop, creating and providing for one of the most basic human needs, clean water. So improved human health and the human condition. Institutional reputation and prestige. This is really important to attracting the highest caliber faculty, staff, and students. I cited one press release here where the NIH Scientific American Science salute a discovery that took place at the University of Virginia. This is really important for our future in a highly competitive higher education landscape. But we also look at the quality of our partners. New Enterprise Associates, the investor in Eric Brewhouse's company Sidekick, is one of the largest and most respected venture capital firms in the United States. Analogic is a medical device company, and Sanofi and Pfizer are both major pharmaceutical companies that have chosen to partner with the University of Virginia to commercialize the results of research taking place at UVA. Faculty, staff, recruitment, and retention, we have to provide outlets for innovation and ultimately products on the market. But we also hope that we can make some money along the way. And when we do make money, all of that money is distributed to reinvest in infrastructure. So 35% of the dollars that we make go to the innovators as personal income. 10% goes to their lab, 10% goes to their school, 10% goes to their department, and 35% is maintained by the Office of the Vice President for Research to support innovation and scholarly activities. So what do the faculty members do with the money? Turns out a bunch of them buy cars. So upper left-hand corner, that license plate says MP Rage. MP Rage is a magnetic resonance imaging pulse sequence technology invented by the two gentlemen standing next to the car. The bottom one, ATL 146E, is an anti-inflammatory therapeutic. The gentleman on the upper right-hand corner is George Gillis, and he pioneered stereotactic surgery and ultimately bought himself a Corvette and put UVA Patent Foundation 1 on his license plate. But it's also reinvested into the innovation infrastructure at the University of Virginia. And so one of our most commercially successful inventions is a drug called adenocard, an anti-arrhythmia agent. That's the chemical structure and that's the brand name. But Bob Byrne, the inventor of that technology, invested a huge amount of those proceeds back into the university to create the Robert M. Byrne Cardiovascular Research Center, one of UVA's flagship programs in its research and development enterprise at the School of Medicine. I think we've already convinced you that we know what we're talking about. Other people are recognizing it too. UVA has been recognized as a star performer in the commercialization of medical products. National Venture Capital Association has highlighted Charlottesville in 2015 as the fastest growing venture finance community in the country. And Entrepreneur magazine called Charlottesville the 4th best place for cities and entrepreneurs to live and launch. So what does the future hold? 2 snapshots. Yanni Kipnis, the gentleman in the upper right-hand corner, is going to develop new therapeutics for the treatment of a wide variety of neurological conditions. Professors Cates and Miller are going to develop totally novel imaging modalities to help us earlier predict and intervene in disease. And ultimately, what does the future hold? UVA is going to win the football game this afternoon. And that's it. Some of those are true. Some of those things will happen. Yeah. And I'm happy to take questions if anyone has any questions. There's a question over here. And all right. You know how to do it. I've worked on civil engineering technologies and tech transfer before.
Is somebody on your staff now involved with the very vast quantity and kind of power units that are in the little hand computers? It seems like we've fallen behind ourselves in track of what to do about improving power sources for electric.
Yeah, and so I think Eric's company is probably the most applicable. The question is, what are we doing to minimize the electronics and better, more efficiently manage power sourcing for handheld medical devices? And Eric mentioned it. In essence, the idea here is that the use case for Eric's technology that I saw the first time it came through my office was there was a Band-Aid patch. Has anyone ever been on a Holter monitor? A Holter monitor is this heart rate monitor that they use, and they send patients home with it for 24 hours, and you got to wear this big hip pack and a bunch of wires and electrodes all over the place. They came in with a use case that was, you just stick a Band-Aid on your chest and do all of those same things. And I was like, well, where's the battery and the hip pack and all of that stuff? They said, well, you don't need it. And I said, where does the power come from? It comes from scavenging the energy that is the differential between your human body and the ambient environment. So in addition to scavenging that energy, you also have to create the chips to operate at an extraordinarily low power. So that's the most applicable use case. But we have faculty members in mechanical that are deriving power from all kinds of different environments in the fabrics of our clothes, in statics, in all kinds of different things. Well, yeah, that is important. I'll check back with them on that.
I've got one here.
Yeah, that's right. Yes, sir.
I think this question's changed about 6 times after listening to the presentation, but more related to the business model. I know we're not short-term here, it's more longer-term, but I saw the $350 million number at the top line. Are there other benchmarks that you have that you can measure how well you're doing?
Yeah, so there's the throughput of our system is one of the big things that we measure. Is okay, so for a $350 million research enterprise, can we normalize that to other bigger institutions and other smaller institutions to ensure that invention disclosure volume is at the level that it should be, transaction volume is at the level that it should be, new venture formation, and all of those things. So our professional society, there's an association called the Association of University Technology Managers that reports annually on innovation metrics from all universities across the country. And so we stack ourselves up right against Stanford and MIT and big institutions, but Michigan, Wisconsin, but we also compare against our peer group in terms of research expenditures. The amazing thing about UVA is our faculty is extraordinarily innovative. Pound for pound, we get invention disclosures among our aspirational peer group in the class of Stanford and MIT. So our faculty disclose at high volumes. We also transact business for those inventions with commercial enterprises at the high volumes with those peer institutions. We actually outperform Stanford and MIT when normalized for research expenditures. So yeah, we look at the input-output metrics. We look at the quality of the partners. We look at magnitude of dollars flowing back and being reinvested. There are a lot of different ways we can look at that. Yes?
Thank you. In the aging world, what most of us are in, I heard something where we die because our cells stop regenerating, and there's research into how we can somehow trick the DNA or other molecular processes to make our cells regenerate longer so we live longer. So what should I be looking at or learning from that you guys might know about to help with that?
All right, so we can take that a lot of different directions. I think that probably the most relevant is gene therapy. The idea of virally infecting cells to drive changes in the way that the genes encode certain cellular functions. And I think that's the field that is probably going to be the future of medicine. Also, and this is a little off topic, but immuno activity. So immuno-oncology is the hottest field right now in therapeutic development, in that it's, in essence, we're not going to try and develop small molecule therapeutics to treat disease. We're going to engineer our own immune system to treat those diseases. So going in and modulating cellular function to use those cells to fight ultimate disease. And we have robust programs in cellular therapies, particularly in the Cancer Center at UVA. I hope that was at least sort of on track. Yeah, certainly.
You've talked a lot about products.
Yes.
And my husband and I spent our careers in Silicon Valley dealing with new products a lot. And where the valley of death you talk about often seems to include a lot about processes and human interaction. That's very hard to patent.
Absolutely.
So would you just talk about how you deal with that a little bit?
Yeah, so when UVA licenses technology, we license really all of the assets that we have. And we talk a lot about products because patents are the easiest thing to draw a box around and illustrate what we're talking about. But increasingly, the more interesting things that are being licensed out of the university, particularly in Chad's case with Type 0, is the data that we've collected. Right? We collect large volumes of data associated with human-patient interaction with insulin or other drugs, and we're licensing data sets so that other people can draw those conclusions from those data sets and not limit it just to our ability to derive conclusions for that. We have licensed methodologies. In most cases, they're patented methodologies, but our licensees then take those products and turn them into services. I mean, you've got a huge service model being built where we're actually not going to sell a thing. You're going to render a service via the cloud that tells a patient that they're about to go into hypoglycemia and you should, attenuate your insulin delivery. So our companies really take it down that commercial path. They take these early assets that we have and then take them the rest of the way. So it was what you were doing in Silicon Valley. We would hand you our thing and our know-how and our data and our processes, and you'd say, how can I productize this thing?
This is our last question.
Yep.
You've talked a lot about licensing your results of your research. Have any independent publicly traded companies originated from your work?
Let's see. A publicly traded company that originated from UVA. First thought is Stereotaxis. I won't say it originated at UVA. Is publicly traded, but was built on foundational discovery at UVA. It's a little early, though. We started in '77. I'd say the real transformation probably took place in the early 2000s. So it probably is a little bit early for that. I'll tell you one I'd watch. Psychic. That's one that the investors that invested in that company are the investors that take companies public. But interestingly for us, a lot of our companies are acquired, particularly on the medical side, post-phase 1, post-phase 2, and are acquired by those publicly traded companies. In the medical device sector, or in medical device and therapeutics, there are aggregators. And there are 5, 6, 7 aggregators that come in and buy up all of these companies. So Forest Labs bought one of our portfolio companies Analogic bought one of our portfolio companies, and they come in and they buy it up and make it a product line in their major divisions. Yep. Well, thank you all very much for being here. I really appreciate your time.
Thank you. On behalf of Life